Hey, hello guys, this is Sanjay. Welcome to my channel. So we covered, first of all, I apologize for giving such a long gap. I had some work to do. So we actually speaking, we finished the chapter of the aldol reactions. So if you haven't watched, uh, uh, go and check it out in the playlist given, so in my channel. So now let's practice some questions, because theory is important, I accept, but after knowing the theory, if you directly go and sit in an exam, you will not be able to answer the questions. So now we'll take some JEE level, or whatever level you want to take it. So the questions are of good level, okay? So you can believe this and revise or practice for a class test or for whatever you want. So let us go and practice some questions based on the concepts. So the first question is here. So this compound is basically a carbonyl compound, so it has C double bond group. The question they are asking is, we have to show the structure of the enols, okay? So first one is enols, second one is stabler one, okay? So we'll go with the mechanism only. So this is the phenyl ring, okay? So pH CH2 C double bond O CH3. So if not mentioned, you can take it in for the the basic condition only. So you can generate this OH minus and give a attack. So there is nothing wrong in doing the mechanism again and again until and unless you're so practiced to it. See, because I can directly add the product if I want, but you will not be able to understand. So I'm writing the mechanism for your practice. So you also kind of pause the video and try it out and get to the answer, okay? So it will come C double bond O CH3. What will happen? pH CH double bond CO minus CH3 H2 pH CH double bond COH CH3. Okay, this is the first enol. Okay, second is also possible like in this way, right? Okay, CH2 C double bond O CH3 OH minus can attack. See, they are asking the possible enols. Out of that we have to say which is stable. You can say we have to directly add the stable enols only, but in the question they are asking the other stable enols, okay? So first you have to write both the enols that why, first of all, why there are only two enols possible, because there are only two alpha carbon, right? Two alpha carbon. So once OH minus can attack at this state, and another in another time it can attack here. So the first product is this one. So when you attack it here, you get pH CH2 C double bond O H2 minus. Okay, now it will rearrange like this. It will go CO minus double bond CH2. You take H2O. So this is second product, okay? It's as simple as that, okay? So you are getting two products, okay? The second question, is two enols. Second question is asking which is the most stable ones. Think it how to judge the stability. This is enol, right? I've studied in the first video itself. For judging stability of enols is what? Actually, it's hydroxyalkene kind of thing. So for alkene, how would you judge the stability? First thing you will see aromaticity. Second thing, aromaticity does not generally stability. I'm saying first thing you will see aromaticity, then a resonance, then hyperconjugation, then if possible some inductive effect. For alkenes, you would see mostly resonance and hyperconjugation. So you see here resonance stabilization exists, right? So you understand what happens? Means I'll write it in the show. Kind of this one. This is the molecule, right? You see, what is this? Pi sigma pi. Resonance exists, right? So like this it happens. So pi sigma pi. So resonance exists. So that is why you can say this is the more stable enol. Okay, this first is more stable one. Okay. So this is the first question. So we'll go to second question. We'll move fast so that we can take more number of questions. So a second question is based on the LDA. You have said it in the video, right? LDA, lithium diisopropylamide. Okay, so it's a strong base actually. It's bulkier basically, so that's why it acts as a strong base. So the question goes like, so this is the question basically. So this is a carbonyl compound LDA. What it will do? Simple. It will remove the this is symmetric, so nothing to worry. It will remove the alpha hydrogen. That is the most acidic hydrogen, right? So it will be like CH2 minus C double bond of CH3. Now comes the catchy point. This is a negative charge kind of thing. It acts as nucleophile. Okay, so this will attack this compound. This given as 2, right? So you can say that this reaction, this no reaction we have not studied in this chapter, but organic chemistry generally is linked. Okay, so we have to see negative charge will attack a positive charge, right? That's simple basic logic. So what will happen is that this negative charge comes and attacks this carbon. Why it comes and attacks this carbon? So this bromine leaves. Bromine is actually strong minus I effect. It has strong minus I effect, so that it has more of delta minus charge, and this has more delta positive charge. So as it approaches this carbon, this leaves, so that the charges balance each other. So plus charge comes and attacks minus charge. So what will happen? CH2. Moreover, if the positive charge forms over here, it is resonance stabilized also. In that way also you can say CH2 double bond CH. So it will be CH2 bond CH2 C double bond of CH. Simple. Okay, this is the product. This negative charge is the bond formed over here. Okay, it's as simple as that. So this is the product formed. So we'll take up another question. The question goes like, so this is the compound given, double ring attached. So again it reacts with first LDA, and it reacts with this molecule. This what? Ethyl iodide. Okay, so what will happen? This is strong base, so it should abstract a proton from less substituted side. Okay, less hindered side, because it's so bulky, right? It cannot abstract a proton from this carbon. This is carbonyl carbon. This is the alpha hydrogen. This alpha hydrogen exists. Okay, like this. Okay, this is alpha hydrogen, and one more alpha hydrogen exists. This side you realize that this is a less hindered side. This is more hindered. So this abstract this proton only. So what happens is that, so minus charge forms over here. This remains unaffected. And when you react it with this molecule, what is this? CH3 CH5. This will react with this carbon, and this iodine leaves, because it's the same reason I said. I is a strong minus I group, so it has significant amounts of negative charge on it, and this has a positive charge. It's simple SN2 reaction. Okay, so I minus is also a good leaving group. Okay, so it will be like, so this forms, if I'm not wrong. Yeah, this forms. Okay, so yeah, so this goes and this forms like this. Simple. So one more you can take. So this is a benzene ring. This is a benzene ring. It forms a double bond O, a 3-membered ring. Okay, so I'll draw in a different fashion. Okay, so it will be like this. Nothing different here, just that I am drawing it in the Kekulé structure only. So this is the compound, right? So now if you see here, there are no alpha hydrogen. You can see, right? 2 1 3 4. Okay, so the LDA, the reaction is LDA and CH3I. Okay, this is the reactant. reagent. So this cannot abstract a proton from here. It should abstract a proton from here only, even though this is a less more hindered side, but there is no other way. Okay, so it will be like negative forms over here and attacks this, and it leaves. So what you get is this compound. This compound will get, sorry, CH3. Okay, this is the reactions of LDA. Okay, we have seen that, right? So we've seen the enol formation also in the first question. So here we saw the how LDA reacts. So we'll take up the next question, fifth question. Now we take up the questions from halogenation. Okay, I'm just revising. You can see the concepts. Okay, they've given proposed mechanism for I'll put the questions in the video. Now we can see on the screen actually. So you don't worry if you can't understand the question, you can read it out from there. So they're asking proposed mechanism for the reaction of cyclohexyl methyl ketone. Cyclohexyl methyl ketone. It's like ethyl methyl ketone. They have given general name. So it will be cyclohexyl. Okay, this is cyclohexyl. My bad. The drawing is so bad. Okay. So cyclohexyl methyl ketone. Okay, cyclohexyl methyl ketone. Okay. So this reacts with excess Br2 in NaOH. What will happen? I've said this in the video. Okay, I think probably in the second lecture. I think so. If bromine is present in excess, okay, and the reaction is happening in the basic condition, what will happen? Halogenation takes place. Okay, basically. So in the halogenation, what happens? Polysubstituted product is formed in case of basic condition. In case of acidic conditions, it will form only monosubstituted product. So that is the catch over here. So if you have doubt why is it happening, please go and watch my lectures. Okay, so what will happen? Simple. Okay, they have said propose a mechanism, so we have to propose it. So we can do that, no problem. So it will be like the what will happen first? OH minus comes, abstracts this one to form double bond CH2 minus. This attacks in the Br molecule. It goes like this one. Okay, so Br. Similarly, OH minus comes, attacks this one until the hydrogen is it is completely used up in the reaction. The reaction goes on. Okay, this goes again in the Br. So it will come and attack this one. This leaves. So what will happen? Br. So similarly, next step it will be what? Another hydrogen is also replaced, right? So it will be CBr3. Okay, and here also there are two alpha hydrogens, right? So again it will be not two. Okay, actually one alpha hydrogen. Sorry, my bad. So this will be the final product. So simple reaction only. So the next question they have asked is predict the products of the following reactions. So we can see, no problem. Sixth question, right? Okay. Predict the products of the following reactions: cyclopentyl, okay, methyl ketone, then written with excess Cl2 excess, NaOH. Same thing happens here. So again, what will happen? Cl double bond O CCl3. Okay, and so next one they have given is they have given is this compound CH3 cyclopentyl, like this, given this compound. So they have given this to react with Cl2 excess NaOH. Now we can think what will happen. There is no carbonyl compound. I said this in my haloform reaction also. This is a typical reaction of haloform reaction. Now see, you realize this can happen also if another excess given, right? So we can take up like this. So the haloform reaction takes place, so that this will form. So this forms. So basically CHCl3 is precipitated out. Okay, so you can write the products up to here also. They are not mentioned any specifications, right? So no problem. It will be O minus, right? This process, right, what happens. So if you want, I'll explain. Okay, you can watch the video. Okay, I think in lecture 2 or 3 I've said about the haloform reaction. What happens actually, again OH minus ion comes and attacks, right? So now there is no alpha hydrogen to attack, so it attacks this carbon only, so that it will be like this. Sorry, O minus OH CCl3. Now this comes over here and this leaves, leading to this compound, double bond OH. Now CCl3 minus exists, right? This captures this proton to form, here Cl exists, okay, to form this compound Cl double bond O minus plus CHCl3. This is chloroform, okay. So this is actually the haloform reaction basically. So here also they have given this alcohol, right? So if you want, in the previous question also you can after this forms you can do like this one, okay, Br O minus plus CHBr3, okay. So this undergoes oxidation, I told, right, in the previous class itself. I mean, sorry, in the haloform reaction lecture, CH2. This alcohol undergoes oxidation to form aldehyde, okay. This is H, aldehyde, okay. So now this undergoes OH minus in absence of Cl. What will happen? All the these two hydrogen there, right? This will undergo chlorination basically. So Cl bond to H. Now the reaction actually stops over here, because the main condition for haloform reaction is what, guys? It should be a methyl ketone. Here it was methyl ketone, here also it was a methyl ketone, right? Here also methyl ketone, but here it is aldehyde. So the reaction stops over here. This is the main product formed, okay. So this is the main catch over here. So understood, right? To the next question. If you have any doubts, you can ask in the comment section, okay. I'll answer, okay. So which compounds will give positive iodoform tests, they've asked. So we can write, they have given this compound. So okay, this compound. So this will undergo what? This will be pH to CH2. Again, this will be aldehyde, right? So no haloform reaction. So next one, pentan 2-one. Okay, you have to be fast drawing in the bond line formulas. Okay, pentan 2-one. This is methyl ketone present. So haloform, yes. Okay, yes, haloform. Okay, so iodoform they given basically. Pentan 2-all. Okay, so next is pentan 2-all. This will undergo oxidation, right? Same compound here. So methyl ketone is present. So yes, it will undergo haloform. Next one, pentan 3-one. Okay, this cannot undergo haloform reaction, because why? There is no methyl ketone present here, so this cannot undergo haloform reaction. Next one, simple, yeah, they given acetone. This can undergo haloform reaction. Methyl ketone present, right? So it's enough, right? 5 examples I've taken. So you practice on your own, and you can ask doubts in the comment section if you want. So this is the 7th question we've taken. We'll take some more questions, no problem. Then next question is, propose a mechanism for the acid catalyzed bromination of pentan 3-one. Okay, what is pentan 3-one? This is right, this is pentan 3-one. Acid catalyzed, sorry, not dehydration, it's bromination. Sorry guys. So Br in the presence of H plus. So for simplicity, I'll say the answer. Okay, you should remember this. It's not so difficult, right? So you can remember, like, this is acid catalyzed, right, and the bromination takes place. So only monosubstrate product will form. So they've asked the mechanism. No problem. We'll write the mechanism. What will happen? So first we'll take this carbon. Okay, H plus. The lone pair subtracts is H plus. So OH plus. Here hydrogen is there, right? Hydrogen is there. So what will happen? In presence of X, this X comes and attacks. Understand the arrow side. This you should be doing it as fast as possible. Okay. So it will be OH double bond. Okay, this is enol plus HX, X plus, you can write whatever. Okay, so now this is the enol formed. Okay, now enol again attacks this halogen and this leaves. How is it attacking? Basically polarized itself as minus plus, so this minus essentially attacks this halogen. Okay, so it leaves as X minus, so it will what happens? So OH, so it will be X, right? So sorry guys. Okay, how can this attack take place on its own, right? It cannot take place. So what will happen? Essentially this will come up like this. So only it will be carbon. This carbon will be pentavalent. 1 2 3 4 and 5. It cannot be. So this bond leaves. Okay, this bond attacks. So it will be OH, plus. Understand, right? If you don't understand, please go and watch the lectures. So what will happen? This essentially leaves, forming this OH minus H plus. So this is the compound formed, right? So what will happen? Suppose, okay, if suppose again, if suppose the reaction should take place again, okay, I mean further, what will happen? This should attack over here and form this double bond H plus and X. So again what will happen? This H, it will, in the presence of XX, will abstract this hydrogen, it will give its bond over here, it will be like this. So OH X, this will happen, right? Now this bond, what happens? This comes over here and this goes and attacks another molecule of halogen, right? But you don't understand this minus I group, strong minus I group. So this decreases the nucleophilicity of this carbon. Okay, what will happen if it comes over here? This will actually polarize over itself here, so that something of this kind will be formed. Okay, understand? Something of this kind will be formed. Okay, negative charge, positive charge. Okay, this will be formed, right? So this positive charge, it is satisfied by this lone pair of electrons. Okay, so positive charge will not be formed. Okay, so this negative charge is reduced by the this minus I effect. Okay, so already there is some significant amount of negative charge, but it is reduced by the halogen. So further reaction taking place is difficult. Right now, if you have any confusion, please go and check it out. The Aldol reaction chapter, wherein I have taken these reactions in some second lecture also. So the reaction now stops over here. So simple, right? You understand? So monosubstrate product forms. So essentially this forms. Okay, this forms. So the next question we will take up. So in the next part I'll cover practice session. Part 2 I'll cover all advanced level questions also of Aldol condensation. Now right now we have covered whatever the reactions we have taken up in the lecture, right? So first we took the ketone inert automerism, that questions also we took here, and second we took the alpha halogenation, that also we took in the haloform reaction, that also we took. So we took, the next we took is Aldol condensation, right? So Aldol condensation and related reactions, condensations, we'll take up in part 2. Until that, you can take up some homework over here. So you can do, okay, 9th question, let it be homework. Okay, so let's take up this compound. Take up this compound only. So first you react it with Br2 1 molar, okay, 1 mole, and in the presence of OH minus, okay, Br2 excess OH minus. Kindly do this, the questions, it will be so useful. 1 mole H plus Br2 excess H plus. So comment below the answers for this question. So I'll see you guys in the part 2, and with that we'll complete this chapter and move on to the next chapter of organic chemistry. So basically this chapter I like it very much, so I took this chapter. So because if you have difficulties in basic of organic chemistry, I'll take up, don't worry, I'll take up the next chapter, the general organic chemistry. From there I'll start and come to hydrocarbons, the aromatic compounds, and finally alkyl halides, alcohols, aldehyde ketones. In aldehyde ketones only you will see in NCERT these reactions, okay, some are not given in NCERT also. So these reactions, then we'll go to amines, then carboxylic acid derivatives, so slowly we'll go up. So kindly forgive me if you did not understand something in these lectures. So if you have any doubt, you can ask in the comment section. So that's all for today, guys. So do up the homework question, and also wherever the questions come on the screen, you can pause it and try it on your own. So that would be of great help for you. So you can comment down this below these answers. So bye bye guys, take care. So we'll meet up soon. Thank you.